Animal farming is a form of bioengineering that makes a farm animal produce mass amounts of a desired drug in its milk. Drugs like insulin or human growth hormone are often used in animal farming because they are needed in large supply for patients with different medical conditions.
Animal farming is based on the process of transgenesis. Transgenesis is a genetical engineering technique that introduces a new foreign gene or transgene into a living organism so that the host exhibits a new trait that can pass on to its offspring.
Animal farming uses transgenesis to incorporate a new protein encoding section of DNA into the host's DNA. The transgene will exist in every cell of the animal's body, but the protein that it encodes for will only be built in the mammary cells. This means that the desired drug the protein makes will only be present in the animal's milk.
The process starts by using restrictive enzymes to cut a section of DNA that encodes for the protein that creates the desired drug. The section is taken out, and the same restrictive enzymes are used to cut a part of the DNA in an embryo made by in vitro fertilization. The selected transgene is injected into the fertilized embryo and incorporated into the DNA.
In order to get the protein to only be produced in the mammary cells, the transgene is paired with a promoter. Promoters signal transcription of the gene it's paired with, but only under certain conditions. In order to choose a successful promoter, the promoter has to work under conditions that only occur in the mammary cell.
Beta-lactoglobulin, or BLG, and beta-casein are just some of the many possible promoters used in this process that are regulated by mammary gland-specific nuclear factors. In other words, they are activated by certain molecular compounds and activities that occur only in mammary cells.
When the transgene and promoter are incorporated into the DNA of the embryo is inserted into a surrogate mother. When the transgenic baby is born, it starts producing the desired drug as soon as the mammary cells mature. Since the mammary gland and milk are not part of the main life support systems, the process is relatively safe for the animal.
The use of the promoter is extremely important. If mass amounts of any desired drug were produced in any of the main life support systems, the animal would die instantly. Isolating the transcription and production of desired drug secretion protein of the mammary glands allows the animal to live a normal, healthy life and pass its transgenes on to offspring.
Animal farming, though still not perfected, has become an essential method to producing drugs in need for patients battling diabetes, cystic fibrosis, hemophilia, osteoporosis, arthritis, malaria, HIV, many vaccines, and other numerous medical conditions.
Using animals for the production of these essential drugs, though controversial, has still been proven countless times to bring little or no harm to the animals it's being used on.